Why did you put it down? I think she could. Or shall I hold the rucksack? I think she can hear us.
Good morning, I can hear you.
Yeah, good to go. Good. Okay. Well, welcome to you all. It's my great privilege to kick off the second series of keynote speeches, and we have a great privilege to host Professor Sergio Savaresi from the Polytechnical. It's so famous that really you just say the Polytechnical rather than say at Milano. Ultimately, he's done a number of degrees from the Polytechnical Milano, and believe it or not, he also did a degree in maths. His research is in control engineering, and in this particularly astute topic, which is so important for our society. And so yesterday we were focusing on a variety of issues on optical wireless and integrated sensing and communications. And of course, that nicely connects to connected vehicles as well. So he's done a huge number of academic papers, but also has got a number of patents, and I'm not exaggerating. He's done 400 plus research projects. So without further ado, join me in welcoming Sergio to the platform.
Thank you very much for the very kind introduction. So to make it's very hot to make things more informal. You allow me to get out of my jacket. So first of all, I would like to thank the organizer for inviting me. I understand that probably my talk will be a bit I wouldn't say out of topic, but a bit different from, let's say, general topics of the conference. I kept it at a relatively high level. I hope you can enjoy it and take home something useful for you. This is a very brief outline of my presentation. Essentially, we'll go through some high-level description of the new mobility models and the impact of autonomous driving, and then to make things more, let's say, specific, I would like to present you two flagship projects we recently developed Polytechnical. One is say the Miglia Autonomous Drive, and the second, the participation to the first autonomous motorsport competition, and then some conclusions, maybe some questions and discussions. Okay, let me start with a very general, let's say, introduction. This picture, you probably well know this type of picture, so I'm probably repeating something well known, but I think it's always useful to start this discussion by showing the problem that we have as a humanity in the next decades. Really in brief, you can see here the cumulative total anthropogenic CO2 emission from let's say pre-industrial era, and you can see that it's about 2000 gigatons of CO2. As a consequence, the temperature anomaly again from pre-industrial era is about 1 degree. Actually now is 1.2, 1.3 indeed. There is a general agreement that we have to stop at 2. We really don't know what's going to happen beyond 2. And the consequence is that human race has a sort of residual budget, which can be roughly estimated in 1,500 2,000 gigatons of CO2. The scary thing is that the equivalence, so if you count, this is just oil, if you count reserves and resources of oil, so the equivalent CO2 emission is much more than 2,000, is about more than 10,000. If you count coal, natural gas, and so on, we go up to 50,000 or something. So we are really going to restrict, we need to restrict ourselves to use a tiny amount of the available fossil fuel resources. This is going to be tough because it's a self-restriction, and you know, there is a lot of political debate on this, but this is the problem we have to face. Anyway, I don't going to enter in the details. You can find this picture on the IPCC. This is what is going to happen if we go up to 4 degrees. It's going to be a disaster. You can see from, let's say, temperature change, moisture change, precipitation change, biodiversity disasters, risk for human health, food production, and so on. So briefly speaking, it's going to be a disaster. So we really have to stay below, not beyond 2.5. Otherwise, the outcome is going to be really disastrous. All the industrial sectors today are trying to go into carbon neutral. That's a general target everybody is targeting. The mobility world, which is responsible of about 30%, there are different ways to count this, but let's say roughly speaking is 1/3 coming from the mobility sector, is trying to move in this direction. And what we do expect is this type of revolution. This is in brief the traditional mobility model, which is essentially fossil fuel based, personal ownership, human driven. And we are going to transition in 10, 20, 30 years. This is the time scale we expect into a totally new different model, which is electric or hydrogen or e-fuel or something. But the idea is that anyway, we are going to start from renewable electric energy production, shared and autonomous. So these are the 3 pillars of the new type of mobility model. Let me now show you some remarks. Let me call them remarks and snapshots. Consider that whenever you see this symbol, they are real data, tons of real data taken from the telematic boxes or black boxes. You know that Italy is a bit unique. We have 7-8 million of cars in Italy equipped with insurance telematic boxes. So we have an enormous amount of real data to understand how people really move. We can do a lot of very advanced simulations. It's a bit of a special benefit we get from this very special, peculiar telematic boxes development in Italy because of cultural reason. Don't want to enter in this, but let's see, these are all from real data. This picture tells you the simultaneously used cars. This is the percentage. This is the time over 24 hours. You can see the classical peaks, rush hours. Notice the number. So despite looks like in the morning at 8, everybody's going on the car, in practice, just 10% of the car are simultaneously used. So it's a really, so most of the cars are not used simultaneously. And this is consistent with the very small mileage of the car in Italy, but in general in Europe, no more than 10,000 kilometers per year. So the outcome is that we have tons of cars. In Italy, we have more than 40 million cars, mostly unused for most of the time. The obvious consequence of this is to move to a car sharing system, car sharing model. You know that car sharing is available today in some cities. For instance, Milano is one of the cities in the world with one of the best developed car sharing system, but still really a niche. It's a service available, but niche for considering the full mobility requirement for Milano. Why? Because today it has limited functionality. So high access time and distance, generally speaking, low availability, high cost. And there is no way car sharing with the current model can develop into a mass market mobility model because of this restriction. So there is no business case, must be subsidized. And with this model, you should use tons of cars almost unused. The only way to develop the only way to develop a sustainable car sharing model or a mobility as a service is to have the availability of autonomous cars. In its most developed situation, which is the, let's say, L5 robotaxi model, very easy to understand, but be careful that would be enough, much less. This is an example of the so-called smart sum of Tesla, just to give you an idea, available only on parking slots. Let me call it L4 minus, so unmanned low speed. That could be enough because of autonomous replacing or rebalancing of the position of the cars. So the problem is that the cars today are always in the wrong place at the right time, or just you can call the car and the car comes to you. So it can incredibly increase the efficiency of the system. So with this technology, you can really go into a sustainable car sharing model. We made some analysis. It's not easy, but it's feasible because of the data we have. So we know today how people move. We took the city of Padua. Notice we didn't take Milano. Milano is an outlier, is a big metropolitan area. Padua is a mid-sized city. There are plenty of them in Italy. And we tried to make a full simulation by providing exactly the same services, the same movement, but with the replacement of private cars with mobility as a service cars. We took a radius 10 kilometers with this fundamental assumption, replacement target, the cars with 90% of their trips in. In means start inside and inside, which are the more easy in the future to be replaced with this mobility as a service system. So let me skip all the details. Of course, it's a quite complicated analysis because you have to simulate everything with this new model. But look at the numbers. We can replace 30% of the cars, which is more than 30,000 cars in Padua. Efficiency, they can be replaced with this number. So efficiency is 8. So we can divide by 8 the number of cars. Other very interesting numbers, level of services, really very high, couple of minutes, 2-3 minutes of waiting time, no more. And this is very important, mileage, almost 50,000 kilometers per year, which is very important, means those cars are actually used. Because the problem for car sharing is when the mileage is small. So the sustainability from a business case point of view comes from the number of kilometers which are done. Some details, but just to show you a snapshot of the analysis. Of course, the number of vehicles can be decided according to the level of service. You can see average waiting time. Of course, if you use just 1,000 cars, you give let's say, poor level of service. With a small number of cars, notice that you have a big mileage, but a lot of that is with empty cars. So it's important to have this orange part small, because that's a part of the travel when the car travels without payload, without the customers and so on. And the final consideration is that it's scalable. So we try to enlarge the radius up to 15-20 kilometers, and it works. So the meaning is that is not something that can work only big cities, high density, can work also in medium-sized cities with some outskirts and small villages around the city. It's worked quite well. It's quite scalable. The second remark I would like to, so let me switch to another topic, which is the electric car. Electric car, there is a big debate today on the electric cars, you know. Again, this is from data, this is Italy, so sorry, this is a focus of Italy, but I think it can be easily extended at least to most European countries. Let me tell you how to read this very informative type of graph. In this case, you can pick up a range. So let's assume you have a car, electric car with 250 kilometers of range. And if you take the blue line, this one, this tells you the percentage of car in Italy that never make more than 250 kilometers per day. So it means in principle, you can recharge just by night at home, or let's say, anyway, on a night recharge model. And if you take out 1 day, 2, 3, 4, 5 days, you can go up, you can see here, 250, you can go up to a huge 80%. This means that if you take all the cars in Italy, let's assume they are electric. Let's assume that you have a 250 kilometer range. If you skip just 5 days per year, 80% of the cars have the right range. This is point one. The second remark is that the real expectation of people is not 250, it's the classical 500. There is sort of pushing towards 500. Notice that 500 is huge. So 500 means 90+% of the car never even 1 day per year make more than 500 kilometers, which is reasonable. So it's a really huge number. Where are the problems? The problem is that, again, average mileage, just 10K per year. And the real bug of this story is this one. So keep in mind that if you have a 500 kilometers range electric car, the lifetime of the battery is 700,000 plus kilometers. Is never going to happen. It's impossible that a private car with this mileage can reach this level. So in practice, we are going to trash our private car with an almost new, apart from calendar aging car. So notice that there is a huge conflict between the expectation, 500, the real mileage of private cars, and the lifetime of the battery. Conclusion, the electric car essentially is unsuited for private mobility. I'm not telling that electric car is the wrong direction. I'm telling you that if you want to go straight to the electrification, we have to shift towards a mobility as a service. That's the point. So I'm in favor of electrification, but we have to keep in mind this point. And this is, from my point of view, the key slide, the key concept I would like to deliver to you and to share with you. So this is the, let me call it the right sequence of the events, or the Consecutio at the Latin word is this one. So first, electrification with personal ownership car can be done, but it's intrinsically limited to 20–30%, no more than that. Beyond that, can be done, of course, but it's, let me say, unsustainable. So it's not a rational solution. The next step is to move to a mobility as a service. And at this point, that's fine. Mobility as a service or car sharing, so the top type of car sharing is perfect for electrification. There is a perfect fit between electrification and mobility as a service. But I try to convince you that moving to this, in order to move to this, we need the autonomous, let's say level 3+ or 4-, whatever you like, or more. So this is going to be the enabling technology. This is going to be, let me call it, the big bang of the mobility model transformation. If you skip this, this is not going to happen. You can force 90%, like Europe today is trying to force that. But keep in mind, I have a strong opinion about that forcing full electrification by keeping the traditional personal ownership model is a bad mistake. Okay, let me make a final comment, a bit out of topic, but I think it's quite important. In this picture, you can see the impact, let's say CO2 cumulated emission and NOx, but let's stay focused on CO2. So today there is the tendency is to cluster in Euro class. Let's say Euro 4 is bad, Euro 6 is fine. So we try to classify this way, but be careful. This is the, let's say, distribution of the cumulated emission of all the cars in Italy. This is low emission, high emission, cumulated the whole year. Notice that the real dependency is not on the Euro 4, 5, 6. Notice that the average goes in this direction, but there is a small difference. The real difference is how you use the car. It's intuitive. So if you have a Euro 6 and you make 50,000 kilometers per year, you have a much, much bigger impact than having a Euro 4 or even Euro 3 or Euro 2 and just 5,000 kilometers. So we have really to swap to a totally different way to measure the impact. It's not like Euro 6 is good, Euro 4 is bad, trash, Euro 4, but how much you really impact on emissions. Notice, for instance, NOx, of course, the direction is this, but there is a huge part of Euro 4 that has very similar emission to Euro 6. Why? Those are people that make a small number of kilometers per year. So we have to really to swap completely the perspective and to cut this way and not to cut this way. How can we do it? With telematics. Of course, today we can digitally measure the real impact. It's not just the label Euro 6, Euro 5, Euro 4. This is, let's say, a very important message we have to deliver. And today we have the technology. The ICT technology allow us to completely move to a classification like this, to a classification like this. Final comment is landing point. In 30 years from now, what we expect is this. So today in Italy, there are 40 million of private cars, let's say combining function and fun. What we expected is that 20, 30 years, there will be a bifurcation. So a small number, let's say 4, 5, 6 millions of robotaxi intensively used, very high-tech cars, very expensive cars, a very tech-equipped car, but a small number, just function. This is not fun. This is just function. And it's a niche, but important niche of emotional vehicles, because we keep in mind, we have to keep in mind that the cars also contain an emotional part, the emotion of ownership, the emotion of driving, probably they will shift into private tracks, private circuits, and so on. So this is the vision, what is going to happen in 30 years. Final remark. It's clear so that COVID, the pandemic, strongly accelerated the development towards virtual mobility. That's obvious. What is happening today is that from one side, we have, let me call it Uberization of the mobility, okay, mobility as a service and so on. On the other side, there is a strong increase of the mobility of the logistics, let me call it Amazonization. And the higher is the virtualization of mobility, the higher is this second direction. So we're going to see more and more projects, not of cars for people, but for logistics. This is one of our projects, but just an example of a totally different direction. So the automatization of the goods delivery, mobility for goods. So if we're going to see the future of our cities in 20, 30 years, the question is how our cities will be in 30 years from now. Scenario number one, this is the one I like. I'm over 50, I like this one. So robotaxis, soft mobility, smart logistics, clean cities, small number of vehicles, electric, small, autonomous, safe, a lot of space for active and soft mobility, or we are going to see a massive penetration of virtual mobility, all the metaverse, all the meta direction. This is another, maybe that in 30 years from now, this is going to be the mobility. So we are not going to talk any longer about physical mobility, but most of the mobility will be virtual. Final comment, it's interesting to see that this is the plot of the urbanization. Okay, the dark is urban people, the light is rural people. 15 years ago, there was a crossover at world level, and the trend was expected to be growing and growing. But after pandemic, we measured a significant flattening of this curve. which means that today a lot of people can work remotely or can study remotely. So there is the phenomenon called digital nomadism, so the digital nomads, which means that you can choose to work whenever you like. So you can go back to rural area, but not to be a farmer, but just to be an engineer, a technician, or a student. So this is going to be another direction where mobility can develop. We have to pay attention also to this direction. Okay, let me now conclude quickly, a lot of slides, but I'm going to scroll them with two flagship projects we have developed recently. The first is Miglia Autonomous Drive. So the idea is, the challenge is to have a project with a lot of road diversity, so long time and road diversity. So this is the positioning and public engagement. So we selected the Miglia, which is a famous race, historical race in Italy, mostly for public engagement. As you can imagine, an enormous difficulty is the authorization. So today it's very difficult in Europe to get authorization for road, to make experiments on autonomous driving on the roads. We apply to this decree, which is called smart roads. In principle, you can do it. A lot of obstacles: car maker permission, road owner permission, supervisor special license, special insurance, check of the equipment, full technical description. You have to have a lot of credits as a requester to make this request. So it's really difficult today to get this permission. We got it. We got it for full crossing of the cities plus a part of highways. So we got the second permission. Historically, just one permission was given a few years ago for a small amount of road. We got the second historical permission in Italy with a much larger mileage that now we want to extend for more than 1,000 kilometers. The idea of the project is to start step one. We just did it. So it's a sort of presentation, Miglia 23, with some small parts in autonomous, then development, and then ideally step three, the full Miglia 24. Let me scroll the car setup, but I'm not going to enter in the details. This is quite classical. So sensing architecture, cameras, LiDARs. You can see here what you can see from them. And the radars, of course. Then positioning, so two GNSS with RTK connection, correction. Computing architecture, okay, super powerful, dedicated computer. Actuation system, we put an overlay actuation system for the steer, for the brake, so it's the easiest way to use an overlay. Power architecture, we have to add some power to supply all this stuff. Network architecture, again, not going to enter in the details. HMI, diagnostic, communication with the pace car in front of the car, diagnostic, and so on and so forth. A lot of simulation requirements. So the decree requires 1,800 kilometers of simulation of the autonomous car in urban, suburban, highway domain, with a lot of requests. I'm going just to scroll them. This is the urban domain, suburban domain, highway domain, many different light and weather and so on in simulation. So a massive request of simulation result. And this is the final result. These are the converted Maserati MC20. This is for development. And the final one was the MC20 Cielo, thanks to Maserati, that gave us this fantastic, very expensive and very cool cars. We just ended this first part, ended really 1 week ago. So I'm really fresh from this exciting experience for the team. This is the unveil in Brescia, the 11th of June. This is some beautiful crossings. So Miglia goes to Rome and go back to Brescia. This is Siena. This is Milano, the 16th of June. I also asked my designer from Politecnico to create this piece of art, let me say. We call it the avatar, just to create, to boost public engagement. So for us, this project is also public engagement. So to attract attention on this technology, trust this technology, and so on and so forth. Some technical focus, just a few words. We are focusing a lot now on the handover between GNSS positioning and 5G positioning. So we are working with the highway company in Italy, especially to cover the tunnels. So where you can hand over from satellite, let's say, global positioning to triangulation with 5G for the positioning. And another, let's say, specific topic we are focusing in is leader tracking. Autonomous mode is one of the possibilities you can work with autonomous driving. We try to focus on all the difficulties when you have a really bent path. This is one of the technical focus, but I mean, there are many of them. Okay. A few words, and then I'm going to finish. A few words on the second flagship project we have developed. It's another really engaging project from the team point of view, from the public engagement point of view. It's the first ever fully autonomous racing competition. It's called Indy Autonomous Challenge. It was launched 3 years ago by the initiative of the state of Indiana. It's called Indy Autonomous Challenge because of this. Essentially, it was funded by the state of Indiana. Let's say the participants were expected to be universities around the world. At the beginning, there were 40 universities that made a first simulation race, and then just 9 universities have been selected, bought the car, and continued this racing. The idea is that to have perfectly identical cars. So the idea is that the hardware, so they are traditional cars, not even electric, has nothing to do with electric car. Well, this is autonomous car, nothing to do with electric or internal combustion engine. Let's say they are Indy-like cars, it's sort of Formula 2 for Indy cars. And okay, each team, we are expected to develop the AI driver, the full stack. So we started from scratch, the full stack, to develop the full stack of the autonomous driver. This is how the car has been transformed. Instead of the driver, there is plenty of hardware. Again, nothing really special. So state-of-the-art cameras, GNSS, radar, LiDAR, computational power, and so on. So the hardware stack is, let's say, high profile, but it's a classical one. And let me stress again, identical. The cars and all the hardware is identical. The challenge is on the software or the algorithm, of course, or the AI driver. The very first event, so this is a bit of a historical event, can be considered the birth of autonomous racing because it was the first ever competition fully autonomous, multi-agent. This makes a lot of difference. It's not just single laps, it's just a really head-to-head competition. High speed, we went up to 280 kilometers per hour, was the CES in Las Vegas circuit, the 7th of January 22. I'm happy that we have been the winner of that historical competition. The final was our friends and enemies, of course, between quotes. We are, of course, friends. There is a lot of friendship between the teams of TUM of Munich. The second competition was October 22 in Dallas, was a bit of in preparation for the second edition of the race in Las Vegas Motor Speedway. Again, it was again the 7th of January 23, again at CES, and again the final was Politecnico di Milano and Munich. So looks like Politecnico and Munich are the best competitors in this. Again, we won this, and it was established the record, for autonomous car speed in an oval circuit, which is 290 kph, 180 miles per hour. So the final was quite exciting. So it was near miss spin of tomb while attempting to pass. In between, our team, the Politecnico Milano team, was invited to make an attempt for the absolute record of speed. It was very exciting because NASA allowed us to use the landing facility of the space shuttle in Cape Canaveral. And at the moment, we are the record holder of absolute speed for an autonomous car, which is 309 kph, 192 miles per hour. So this was is not that difficult, but you go straight. But it's an iconic place, an iconic record. Very recently, this year, this competition got out of the US. So the first time in Monza was the first competition out of the US and on a so-called road course. No more ovals, which are indeed quite difficult. So oval looks simple, but it's quite difficult. Again, so the competition ended just a few days ago. So this Sunday. And again, we have been the winner, very happy to be the winner on our local circuit. And again, set the, let's say, current record for road course circuit. This is the speed. It's again, let me stress again that it's a very engaging experience for the team. So not only for me, but I mean, the young people working on this project are really engaged. You can see the people, the faces, the enthusiasm. So it really catches a lot of let's say, emotional engagement from these super brilliant young engineers. You can see from the faces and from the team. Dark part of this moon, a dark part of the story. Looks nice, but it's a really difficult game. Watch this. First time I show in public this. This is the final result. You probably noticed that in Monza, we did race not with our nice yellow car, but with this, which is a mule, which is a spare car, because 10 days before the race in Monza, we crashed, and you can see again in the video. We crashed because of a traditional mechanical failure of the steer. The meaning is that going that speed is really difficult because you make one small mistake or you have one small hardware failure and you end up in this way. It's going to be really very expensive. So technically speaking, in Monza, we had two important challenges. One was the localization GNSS free. So this part of Monza, you can see here in the video. So sorry for the mosquito on the camera. This part, which is the Curva del Serraglio and the back straight, Variante Ascari you get again, is essentially GNSS blind. So because of canyoning, there is the tunnel, there are the trees and so on, you get a very poor GNSS connection. So the challenge was to make localization at 250 kilometers per hour. So it's not that difficult at 50 kilometers per hour. 250 is really challenging to go that speed blind from the GNSS point of view, using just LiDARs and cameras. And the first challenge was to have connectivity on 5G only. So Vodafone Business was the partner of this initiative. It was another challenge for that speed. Notice that is not remote control. So we don't need to control the car remotely, but we need a super reliable monitoring and telemetry, because you can understand that monitoring from the control room, the car going alone, totally autonomous at this speed is quite important. Okay, that's it. Finished. Conclusion, very simple. I hope to was clear that my perspective is that the autonomous car will revolutionize the mobility model, is the big bang, is the enabler for the new mobility model. Technology, honestly speaking, is well developed, but still immature, not still ready for a real level 4, level 5, probably is going to take another 10 years to get that level. And the final remark is that pushing the limit of this technology, like in racing, will speed up the development and acceptance process. From one side, let's say public engagement, from the other side, pushing this technology. So in autonomous racing, we discovered a lot of issues, a lot of problems, a lot of opportunities to solve the problems when you really go in the very limit of this technology. Okay, thank you for your attention.
Well, thank you so much for this inspiring keynote lecture. You certainly know how to set our minds at heart racing. Privately, I would have lots of other questions, but I would like to turn to the audience, and really we're looking for questions, quick clarifications.
Hermann Brandt, so I work for IEEE, the Vienna office. Thank you for your presentation. My question is, when do you expect highly automated vehicles on public roads?
On public road. Okay, this is a question. So the honest answer that everybody should give to your question is, we don't know. This is the only honest question everybody, not just me, should deliver. Because there are a lot of items that should be solved. One is technical, in the sense that technically speaking, we are really not prepared. We in a general sense, the technology is not prepared to have a fully reliable localization. Let me say that probably localization issue is the toughest problem. Because once you have a perfect and reliable localization, all the other topics can be solved in some sense. Still, so let's say we're 95%, but the final 10% is going to be tough. There are a lot of legislation issue because despite in Italy, there are 1,000 people killed every year, and the mortality for car accidents is the highest reason for young people death. Probably you don't know that in Italy, but I guess everywhere. The mortality of young people, let's say 20, 30 years, is the first reason for people death. The general acceptance of one killed people from technology is still 0. So it's not accepted. So we accept 1,000 people killed for stupid humans. We don't accept one killed people for technology. And this is a quite big mountain to climb. This is why you can probably notice that Miglia, I pushed a lot also on the, let me call it public engagement, because you have to deliver the message. Let's say, this is a technology, this is important, it's going to be there, and so on and so forth. And many other reasons why it's not going to happen in a few years. My thumb estimation is that it's going to take 10, 15, 20 years to be really deployed, to have impact on, let's say, mass market mobility. But the honest answer is, we don't know.
So if you get 10 times the funding, would it halve the time?
Well, maybe.
That's how a true researcher thinks, right? Is there any more quick question? All right.
Hi, I'm Siamed Nas. I'm from Aalto University, Finland. First of all, this is a very hot topic, and like this autonomous car. However, I have two maybe quick questions. One for the energy consumption. So we see a lot of devices are built with the car, but how would be the energy total if we going to deploy this or to make it in public? And also the second question, since the cameras is vital components, how about privacy? Is it dealt in some way, or do we see some hope that privacy won't be an issue if we move towards autonomous car? Thank you.
Okay. The first, so energy, when you say energy, you mean energy absorbed by the electronics of the car? Okay. I mean, I think it's overrated. So if you want to, let's say, the rough estimation to have a full stack of autonomous driving is less than 1 kilowatt, which is something, but let's say no comparable to the movement energy of the car. And this is very important. With an autonomous car, you can highly optimize the energy consumption of the movement, of the motion. There is a lot of potential so this is much more the gain of optimizing the movement energy of absorption rather than the amount of energy you need for supplying power to the electronics. So from that point of view, let me say very easily that the autonomous car is going to be energy efficient for sure. The second one, okay, I'm not an expert of that, but my feeling is that, let's say, we don't need to store the cameras. We can process online. I don't see it as a real problem, honestly. And I don't see another question today is about AI, you know, that Italy is a bit critical about AI, limiting AI. This AI is for let's say, it's AI applied to physical systems, which has typically a much lot acceptance, not like the full digital AI, which is a bit more debatable, let me put this way. So again, it's an issue, what you're right. I don't think it's a major issue for the deployment of this technology.
Well, thank you so much, really, for coming to talk to us just a few days after Monza. And so you must be still in a state of mind, which is, you know, exuberance, really, after winning all these competitions. It's really fantastic.
Thank you.
So join me in thanking Professor Savaresi again. This is the time for us to move on to the second keynote of the morning. And that fits really very nicely to a subject area like this, because I could view everything. The first industrial revolution was